Due to the superposition principle, waves execute something which we call interference. Interference means the addition of waves, and it can sometimes go toward the net sum or sometimes can cancel waves altogether. If we look at this picture right here, you see two droplets of water that have fallen into a pool. And as they do so, waves ripple out from either one. When those wavefronts meet one another, the one from the left droplet and the one from the right, you can see that some interesting effects have occurred. They add together to make a net displacement. In other words, if we're standing at that intersection, we don't perceive two wavefronts, we just perceive the sum. If the waves are in phase, their displacement add together and they're said to add constructively. That occurs right where we've circled, right about there. And you can see that the amplitude is quite large. Or there, the trough is quite large. If the waves are out of phase, their displacements tend to cancel one another, and these are said to add destructively. In other words, the net displacement can be zero, even though the displacement from either wave alone would be quite large, were it not there for the second wave adding destructively to the wavefront. The type of wavefront depends on the type of interference that you'll get at a location depends on the wavelengths of the incoming waves and how far apart the sources are from each other. Here are two graphs of traveling sine waves that have overlapped, and we can imagine what will happen to their net sum. We'll categorize several of these positions as to whether or not they are destructive or constructive interference. At location G, for example, both waves have a positive displacement above the horizontal line of no displacement, and therefore these two waves at this location would be said to have constructive interference. At location H, however, the longer wavelength wave here has a positive displacement, while the shorter wavelength wave here has a large net negative displacement. These two would then be said to have a destructive addition. At location I, again, the short wavelength wave is going in a different direction than the long wavelength wave, except now the short wavelength wave has a positive displacement, while the long wavelength wave has a negative displacement. Once again, at this location I, they would be said to have a destructive addition. At J, however, both waves have a negative displacement, and we would again say that these have a constructive addition. Can you determine the similar nature of the interference at other locations like K, L, M, N, or O? A single point source like your finger poking in the water creates spherical outgoing waves or circular outgoing waves. That means crests and troughs heading out in all directions. It by itself cannot create interference. But 2-point sources, when they are both acting, the sum of these two can be said to be adding constructively or destructively. That's when the interference effect takes place, whenever there are two waves. And you can see at various locations there are strong periods or places of net constructive interference and places where there seems to be no wave at all. In other words, the amplitude is zero, and that's destructive interference. You can get that kind of interference effect in multiple ways. Here's in fact a single source creating outgoing circular waves in all directions, except there's a wall down at the bottom here, and it's causing reflections of that spherical wave back toward the source. And then the source, which is still vibrating, has a wavefront that's interfering with the one that's reflecting off the wall. And again, you can see regions of constructive interference and regions of destructive interference. This line behind the source seems to have no wave whatsoever. Notice, though, that if the point source is farther away from the wall, now that pattern of constructive and destructive interference really does change. The zones of where the quiet regions are, where there's destructive interference, is quite different than it was in the top picture. So constructive and destructive interference really does matter about how far away the two sources are, what their relative wavelength and frequency are. And you'll get different patterns depending on the placement of these two sources.